it's much easier to understand an autonomous system. If we think about an autonomous system, potentially doing a better job than systems people have deployed today.
Benjamin Hickey. I'm so excited for this podcast. Actually, I've been thinking about it for most of the day because we haven't met. This is the first time we've met. And so my experience is going to be the same as the audience's experience. So Ben, I just want to first say welcome.
Yeah, thanks, Nick. No, I've been looking forward to it as well. I'm looking forward to being at ONUG next week. And I think you've done a great job, bringing together the sort of the networking professionals across industries. That this is something that will be very timely in terms of what we're going to talk about today. But yeah, looking forward to chatting to you.
Awesome, great, and I'm super excited for the conference. It's going to be our biggest one. The registration numbers are off the chart, so I'm really looking forward to it. And also you're doing a keynote on day one, so we're gonna get to that. But I think for both me and I think also for the audience, what we like to do on the podcast is to introduce thought leaders to the community, and clearly you're one of them. So why don't you talk a little bit about your career and your journey? And it'd be really interesting also if you think back over your journey, was there one person or maybe was there one kind of major decision that took you into a different kind of vector that you weren't planning on? So
yeah, I think it's good. Like I saw that question earlier, I thought actually that's probably the toughest question out of the lot. I have to think about that. I laughed to myself. I used to have this saying. I used to say, I used to be a network engineer, and that's how I used to introduce myself. And then one of my probably one of the smartest engineers I've ever worked with, and one I've worked with for the longest time, back when I was in our startup, he made this crack back one time. He said, well, everyone that used to be engineer stopped being an engineer for a reason, and he winked. So I was like, oh, right. So he think I wasn't a very good engineer, and so that's kind of what. But it was a good thing, and that probably talks a little bit. I've jumped backwards and forwards from tech and consulting, and so I've kind of feel like I've been quite fortunate because I've had the deep tech. I've Cisco and Juniper in the heyday, a few other technology companies, and been a co-founder in a startup with Andrew Coward, who and Nitin. Was big, but then on the consulting side, Accenture and Booz and Co. And as an independent, it's kind of really given me this ability to sort of talk business to business people like execs and clients and things like that, but to be able to talk tech to engineers. And so that's kind of what I've tried to aim for, is that point where you can straddle those two domains. So yeah, that's really what I focus. And I think product is actually probably the best job in a firm for that, because it puts you at that intersection with an opportunity to have pretty huge impact for the organization.
Yeah, awesome. I think whenever you have when you're doing kind of consulting work, you're really interacting with consumers a lot, and you're doing kind of planning and understanding their requirements, and then plotting out directions that they can go, and then you take that into the product side of things. I think professionals in our industry that can straddle both the consumer side and then also the product side are the most successful, frankly. And it seems like you have that, as well. You've both been kind of a network engineer, so you kind of the difficulties of being, a network engineer and what it is to run and manage infrastructure. And then also not just having that one experience, but also having the experience of doing consulting work and learning from others, right?
Yeah, I think that's right. I think communication skills are absolutely critical there. That having lived it as well, I think one of the advantages for us old guys in this industry is sometimes the tech's kind of just reinventing itself. But that experience kind of still is valuable today with everything new that's kind of going on. But yes, being able to kind of communicate and with everything that's happening, all the value, like in personally, the value getting out of AI tools today, still being able to craft that story, being able to communicate with people is something that's going to be important for us kind of going forward.
Yeah, for sure. So, all right, so let's kind of dive in. So all right, so great. So you've kind of, the whole life cycle management of infrastructure, from multiple different points of view. I know in your keynote, you're going to be talking about automation around the infrastructure and its life cycle management. So I think where most are in the industry today is they're just starting to experiment with co-pilots. But there's a whole range of tools around to automate this infrastructure. So why don't we first start maybe on your, perspective on automation, and whether that is AI ops or whether it's automation that gets built within the infrastructure itself. So why don't we start there?
Yeah, I think it's good. And to be honest, we're playing on this a little bit. In reality, I think it's important. Let's recognize, right? Automation, we've been doing this for a while, right? This isn't anything new in networks. And I think in particular, there's some intractable problems in trying to deploy automation in networks. We have challenges across domains, we have challenges across vendors, we have challenges across layers. In reality, one of the things I often talk about right now, especially working at IBM, which fundamentally is an application company, right?
Right.
Talk about how networks are different, and one of the key things that all that my folks, my comrades in the networking side of things quickly understand, but you have to explain to an application person, is networks are fundamentally different because they're distributed systems. And as a distributed system, these aren't things that you just go and deploy and roll out a config and come back and check later, and it's still running on that config. These are systems that start to communicate with one another. That operational state is built through interactions that distributed system runs with. So it's a routing protocol across a network, whether it's a link layer protocol with spanning tree or what have you in a layer 2 network, whether it's optical network. So these are fundamental differences, and that means networks have this problem we refer to as a shared fates problem. So that means, you've got the butterfly effect. One thing can go wrong in one part of the network, you can propagate everywhere, right? Now, in contrast, applications, whether they're the old monoliths or new modern microservice applications, well, they're designed with isolation in mind, like out of the gate. They're designed with, how do I recover from the failure if this component fails? So I've got backup, auto scaling, auto failover, and that's kind of quite a different situation. So that actually is probably one of the most intractable problems, because as network engineers, we're dealing with this. It's a complex system. It's very hard, and you only have to look at the progression of testing. Testing from dev environments to pre-prod environments. How difficult it is to try and realize this digital twin vision, because they're complex systems. Your model is always a subset of your reality, right? It's not a full realization of that. And so if test is always going to be limited, you're always going to have these limitations, and you're going to have this automation that might deploy something that can have a butterfly effect. Well, that's kind of the intractable problem. That's kind of what's held us back. So trust is kind of what I'm getting to here. And we've really been limited by these rules-based systems, these rules-based approaches to automation, because everything's so narrowly focused. It needs to be preconceived. You need to think of every possible permutation or scenario, and that quickly becomes inconceivable.
No, there are two, it's really so interesting, and kind of always known, that networks are distributed systems and how different they are from applications. And I don't know why, but I just thought of it right now as you were talking, Ben, is that, the next thing that's going to be truly a distributed system are going to be agents. And and so it's so if we can imagine, and this will happen really quick, where a large corporation might have thousands to tens of thousands of agents, and those agents are communicating with each other. And clearly, there's part of that. There's going to be kind of a client server model using the MCP stuff. Discovery is going to be kind of centralized, but we have that. Those are kind of shared services that we have, like in networking, like DNS and so forth. But it's almost like the agent overlay, the kind of agentic AI is going to be essentially an overlay on top of a distributed network. And I really haven't kind of thought about that until you really just mentioned that. And that's kind of interesting, because I think then it's like, okay, well then who really is in the best position to build and deploy or really, I guess, enable, agents. And you would think that people who really understand distributed systems, which are really networking people, understand it. But anyways, so I just wanted to kind of like, capture that, because I thought that was, if I do say so myself, I thought it was an interesting thought. It came from me.
I think, I mean, we're segueing here, but, we've been talking about this a little bit, and even some of my sort of, little rabbit holes that are down in LinkedIn, you know what I mean, with some of my colleagues that are pretty deep in this space. There's just this idea. I mean, we talk about goal alignment with agents right now with LLMs, right?
Yeah.
You can quickly see how difficult that is within a single agent, a single LLM. Now, if you start thinking about goal alignment across agents, and then agents that are built by different people, right?
Yeah.
So it takes me back to some of my days in networking. Back in broadband was one of the things I really dove into back in the days. And if you think back in broadband, true and mobile too, things like AAA were important, but AAA doesn't even get to the most difficult part of this, right? So AAA's absolutely got to come along when we think about MCP, networks of agents working together. Just like in broadband, they span administrative domains, they span trust boundaries, so you're going to need that. You're going to need to deal with crazy conditions like flash conditions, flash flood conditions. But then fundamentally, it's like, how do you want to expose the experience which you're offering with your agent to another agent when you might not know what that agent's goals are, what its intentions, in order to know whether you should offer up this tool, allow that tool to be called, you know what I mean, and vice versa. So I think that's a very interesting area. We got to work through that. I think that's really important. It's something that we think a lot about right now when we think about it from not just a POC. I mean, it's very easy. You don't have to look too far to see how quickly people have spun up agents and they've got them talking to one another via MCP. These are all pocketable things. These are what you could think about from low consequence environments, right? These are things like, even in reality, like I could get that to look at my email, my calendar, do some planning for me on a day-to-day, but it's a low consequence environment. Like if that screws up, I might be a bit embarrassing. It might do something really embarrassing, but it's not something that's going to really, bring down some infrastructure or get the company on the front page of the Wall Street Journal or something, right?
Yeah.
So
for all the wrong reasons.
Yeah, right. We're back to networks. We're back to that butterfly effect problem. We're back to that trust, right? So that's really when we think about this. We're playing on this autonomy to just recognize what's been going on. What are some of those intractable problems? And so probably a tagline we've got. We think agents are absolutely going to be valuable. They're absolutely necessary, but they're not sufficient. And so agents are going to react to the data they're given.
Yeah.
And if the data you feed them is noisy, if it's difficult to discern the signal from the noise, if it's conflicting or hard to correlate, then your agents are really going to be limited to the systems. The ceiling is going to be imposed upon them based on the data coming out of the systems you give them in the first place. And so that's really something we've taken. And if we move, I've tried to dispel this autonomous networks idea, and I think it's much easier to understand an autonomous system. If we think about an autonomous system, potentially doing a better job in systems people have deployed today, we would say that the agents, the reasoning, huge advances over the last 6 to 12 months, right? It's analogous to what we would call, in the context of a brain, right brain creative thinking. But a brain doesn't just have creative thinking. It also has analytical thinking. that left brain thinking. And so we think our autonomous system needs to address the analytics. We need to improve the signal to noise ratio coming out of that data on that systems in order to do that. So if engineers today, if they're trying to build some automation, what holds them back from taking a particular event and writing some automation? It could be a script, it could be some code they've written, it could be a workflow tool, it could be an Ansible playbook. But one of the fundamental things that stops them just having that automation trigger off of that event is invariably that event, that data, that observability is not very trustworthy.
Yeah. So I am going kind of like in a couple of different directions, here. I'm going to try to kind of take where we are and kind of bring us, back in line with I think where we wanted to kind of deal with around autonomy. It's dawned on me after hearing you talk is that a lot of work that we're doing, especially around kind of operations and NOCs and SOCs and their automation, is going to be very much aligned with what we're going to do with agents, because agents you got to make sure they don't go rogue. You need to authenticate them. You need to make sure that they're not having access to particular data that you don't need to have access in. There are agents that are going to be, kind of multi-agents in multiple different domains, solving domains that you don't have. And a lot of these problems we actually did solve in the networking industry, basically in the 90s and in the early noughts. But I think, in kind of the automation piece, I think where it kind of ties into the agentic discussion is that whole discussion around the data, the policy, and what kind of guardrails you put in, right? And so I think that, those are kind of all prerequisites, for building kind of systems that are autonomous, and where agents would just kind of feed off of that. So let's talk about that. Like, as we're now just starting, I think, to really kind of utilize AI, whether that's in operations or whether that's in the infrastructure itself. So, Ben, maybe let's first talk about AI within the network infrastructure, within the fabric, and kind of what you see happening there and how that might progress. And what you should, if you're kind of a network engineer right now and you're listening in, what should you be thinking about, to integrate or to bring into your infrastructure within the next 12 to 18 month time frame? Okay.
Yeah, absolutely. And I think if you're on, critical, things that are really table stakes from a B2B standpoint, from an enterprise standpoint, and then, even more so from a critical infrastructure standpoint. So, we're using this term, you've seen some people out there refer to now, but, we talk about LLM scaffolding, so it's the scaffolding you put around your system to make it reliable. And there's a lot of things that go into that, right? There's things like you said, there's guardrails, there's obvious stuff like that, but there's a lot more as well. And there's things that we need to think about as well, like, well, how do we develop prompts? Just as we're seeing a rapid evolution of people's prompt engineering skills, we saw those documents leaked from all the big AI labs. In many ways, it's starting to look like coding more and more, right? So how do you actually develop standardized prompts where you've got good approaches to variables in order to get more consistent outputs? And why is that? Well, because we're fundamentally dealing with LLMs that are non-deterministic. And so we also have to handle things like benchmarking. And we're using that benchmarking to be able to catch things like hallucinations and to know, is this output appropriate? Some of these LLMs, if you're using an open source LLM out there that's been trained on the plethora of information on the internet, sometimes I joke, it knows how to bake cakes, plan missions to the moon. There's even been talk of some of them knowing how to, not that you'd want to know, but how to poison your spouse slowly, right? But these are not things you want coming out in a business environment. So these are fundamental, guardrails, and it's a moving target. So all of this is really, we put under the banner of this kind of LLM scaffolding. And that's table stake to do any deployment. So everything that we do in those low consequence environments, we can do as a POC, we can muck around with, we can show, the art of the possible. But to get to something that we might deploy in a production environment, something we might rely upon from a critical system supporting our critical infrastructure, the network, we need to address that. And so the problem emerges, a lot of the approaches people have taken today in enterprise has been, it's back to the old build versus buy. People have taken the approach of the DIY and they're building it themselves. And that's absolutely right, because that's leading to this innovation. People are exploring what's possible and it's giving them insights about what they could do themselves. I think what's going to happen in the market, and you're seeing it more and more with just the rapid rise and records being broken with adoption and time to 100 million ARR, it just keeps getting shorter and shorter. More and more products are going to come where that's kind of taken care of, right? So that's scaffolding. So this should start to be a problem for our enterprise environments and critical infrastructure environments, where that's something you can opt to buy versus build. And you get a bunch of benefits if you're buying here, because you're going to tap into organizations that have got expertise in this area. They're doing it well, but they're doing it once. So there's actually economies of scope here. So you get to do it once in one organization and test it, use red teaming, all of those approaches. And then that can be benefited rather than clients having to reinvent the wheel from a DIY standpoint. So that's really critical on the agentic side. But as I mentioned before, we've got to tackle the analytical side as well. We've got to look at the data, and I think we're going to get that in a minute. But yeah, just to zero in on what you were asking there, about the agents and how we make that a reality.
So give me an example of LLM scaffolding, like what the implementation would look like. How does that look?
Yeah, so a really simple one is it's just if we take something that a lot of people will be able to identify with, it's prompts. So you got your prompt engineering. So a prompt's no longer, we're quickly moving away from just having a chat with a chat bot, right? Typing a few questions, a sentence here or there. So now when we're defining prompts, you're actually starting to define sections. You have parameters when you prompt. And if you're seeing the latest guidance on this, you're going to define key sections. Whether you're using tags like XML kind of tags or you're just using headings, but you want to tell the system what role you want it to play. You want to give it the context.
Okay.
You want to clearly define the task you want it to perform. You want to clearly define what you want the output to be. And I'm even simplifying that down right now. So as you get these standardized prompts, and we're then going to have this library of standardized prompts in the scaffolding, and we're going to use these prompts to inside the product experience that we would provide. Yeah, sometimes I joke our job of creating agents in our product is somewhat simplified because, we've locked our agents in the product. We've given them one job in life to worry about. They don't have a super wide breadth. So our agents that we're building inside our product have a very clearly defined scope. And so the prompts they use for the different tasks that they're going to go on the path of reasoning within the product are actually going to use these standardized prompt templates. And that's helping you reduce the variability in what's a non-deterministic system, right? So just a simple example there, but that's kind of the stuff you want to invest in your scaffolding to get this reliable experience in an enterprise context.
Okay, great. Excellent, Ben. So two things. First of all, your dog, feel free to kind of bring him up and introduce him to everybody. It's like, it's all good.
It's kind of like it's getting dark. It's time to go for a walk. It's time to get some dinner. So sorry there.
No need to be sorry. We're big dog lovers. So kind of getting back into the knitting. So is the scaffolding that you're talking about, and really let's focus in on the IBM products, right? So is it focused for assist for network engineers that are in operational roles, like in the NOC, or is it, for the design, build, kind of aspect of the life cycle? So I guess like where are your products kind of focusing on in the kind of in the network life cycle?
Yeah. So look, at a high level, let me quickly address. I mean, we have a vision where we ultimately see the value here is to address the entire life cycle.
Yeah.
We started with the operations side of things, the day two operations, networks that are deployed. There's a couple of key reasons for that. And so we are building a product. And what I distinguish, and, as IBM, we're a big company, we're an old company, we've got a lot of products, right? We have products, and under the Watson banner, we have Watson X. So we have an AI design studio. So that would be used for people that want to build their own systems. That's really targeted at users that are data scientists, someone that wants to bring an open source model, train that model with their own proprietary data, leverage a team of software developers to build their own application, right? The product we're building in my team is for network engineers, not data scientists, right?
Yeah.
So we're building it. You can use it as an engineer. You don't have to be a data scientist or a software developer. And in the operation side of things, it's a tricky one because it's a double-edged sword. On the one side, we know there's a lot of value to be created here that has not been solved. But on the flip side, this is what Sequoia Capital call a hard fact problem. These are problems that people have come to just accept as being suboptimal. And they've just come to just accept they got to live with the way these things are. There's firefighting, there's poor quality data from systems, data and systems are siloed. You have war room calls that last hours, if not days, on complex cases, complex issues, because teams are talking to one another, trying to share expertise. People are swivel chairing between systems. So there's value there, but people have come to accept that that's what it is. That's what it's hard fact. So, but what we think we're onto here, and what we're showing with the early findings, is that if you can show step improvements over the systems that people have today, and if you can show things can be done which have not been able to be done before, then you can get their attention. People will go back and recheck their assumptions. And that's kind of what you need to do with a hard fact problem. You need to really shock people, shake them up, if you like, to say, there could be a better way for them to go back and recheck those assumptions. That's where we're kind of starting, and the hidden agenda here is the data, so once we start to work with the operational data, which is plentiful, just think amount of telemetry data we collect from networks, all those logs, those alarms, that collect all the IP fixed data, the net flow, the traces, right? It's a lot of data, right? So once we get that data being leveraged by the AI systems, that's going to give us the platform. It's going to give us the base upon which we truly know how our networks are operating now. We're able to know how our network in our domain, in our geos, on our fiber or our circuits is operating, what we're getting from it from a performance standpoint. That allows us to move backwards in the life cycle. And this is the future, right, that we see. In the future, you can actually get to day one if you think about how do you build networks. There's a lot of manual process there right now. And because it's manual, people do things in fairly large step increments. So having to deploy lots of CapEx in large blocks ahead of time, just in case. What about our sort of pithy, clever marketing people came up with this term, we're saying in the future, you're going to be able to deploy CapEx just in time instead of just in case, right?
Yes.
And that's, as network people, as network engineers, we're risk adverse people. We're worried about failures, and we're worried about being on the front page of the newspaper, an outage. And so what do? We throw CapEx at the problem. We throw money at the redundancy problem. So as we start to optimize that, we optimize CapEx, we start to talk about benefits from AI that aren't just OpEx related, but ultimately take that back again to the design too. Sorry, you were going to ask a question there.
Yeah, no, it's okay. Okay, so I'm focused in now. So I think, so the data that you're talking about is all system data around networking. So these are all the logs and the traces and the alerts, the net flows, the S flows, all of that data. And you're right, it is massive and it is huge. Are you basically bringing that up into a data lake, or are you keeping it local and putting agents into the infrastructure? So to make it more of a distributed, approach towards automation than, like a Snowflake or a Splunk or, some other, like I said, kind of like data lake environment. So like, what's your approach with that, first of all?
Yeah, I think, what we recognize right now is those data lakes, those systems of record, they have a lot of requirements attached to them around compliance, regulatory requirements, the need to hold a certain amount of data at a certain fidelity for a certain period of time, lawful intercept requirements, things like that in telco environments. So there's a lot attached to that, and that's not something you want to bite off and try and swallow in a single go. So that those systems and the reliability from that is actually best continue to be handled with those existing systems. But taking data from those systems, if you think about what we talked about before with agents, trying to remove that ceiling, that limitation of them getting a better signal to noise ratio, we want to put it through an analytical AI system to feed it to those agents. And there's been some real advances in that space.
I see.
Not often talked about, but some work that IBM research has done around time series foundation models. I won't steal too much of the thunder from next week, but that really allows us to start to break down the siloed data and systems and look at data like performance metrics, telemetry data, and to then look at that in unison with alarms and logs and traces to get a better signal to noise ratio. This sort of fundamentally flipping on its head how we do anomaly detection in the first place, because now with these analytical AI systems, for the first time, we can look at the data as it's coming in. We don't have to use things like thresholds or alerts to say, hey, I'm going to use a proxy. I guess, if something starts to go bad, it might go around 80%. So here's the threshold. Send me an alarm, send me an alert. If it hits that, well, guess what? Things don't go from 1 to 80% over in a second, right? They degrade. And you know what? If you're dependent upon a threshold to see something's going wrong, and then you have to go back and look for what's really going wrong, then it's always reactive. As you start to think data through this, we can now start with these time series foundation models to actually get a read from what's happening with the data, and then give that signal to the agents that are going to do a much better job with reasoning what's going on and what you should do about it.
Yeah, I think this is super. This is great. So really, I think we're kind of talking about, I can understand the whole lifecycle management, that's here. So we're basically taking advantage of all of the system data that would normally get stored into proprietary systems. And then there are very specific applications that one can run on that. What you're talking about, here is that you kind of aggregate a lot of this data into kind of an AI analytics engine. And then with even a timestamp, kind of series or analysis on it, so you can actually go back in time to kind of see how this network is behaving, at various different points. So you can identify anomalous behavior, you can identify signatures better, because there's no better source of truth than network data. This data is like, if you're really looking for a source of truth about what's really happening within your infrastructure, it's network data. So you're building upon a really good source of truth, to do all this analytics. And then I think, it's like once you start to utilize, these systems as an adjunct, an assist to kind of the engineers who are running kind of the operations, centers, you can also then, provide input into the design as well and capacity planning. You're right, for as long as I can remember in our industry, we always design for what we assume is going to be peak load. And so we spend a ton of money, guessing what that peak load is going to be and making sure that we have enough of it. So if we can get to a more intelligent way in which in terms of we scale and size, then that's a huge win. And that's obviously that's a huge kind of economic benefit towards both the products that you're selling and then also just to automation as well. So it seems, Ben, is that some of the prerequisites here is that to really kind of understand and get a handle on the data. There's policy. We haven't talked about that. Is okay, like, what kind of policies do you want to put in place? And those policies, I would think, could be a lot different than ACLs that we've done before and firewall rules and so forth, but we can put different kinds of policies into this infrastructure that the analytics engine could work on and then see and make sure that those policies are being adhered to. And then those can also be guardrails. So I think that's kind of like where all of that is happening, right? So it's, table stakes, you need all the data. The data is going into kind of an IBM AI kind of analytics engine that really understands the networking infrastructure. And then you can do policy against that, guardrails around against that, a whole range of different applications, in addition to operations, right? So it's like going into design. So is that right?
Yeah. I mean, I sometimes joke, again, back to my my joke at the beginning about used to being a network. I mean, back in the old CCIE days, I mean, I think about how we do design. It's really pattern matching, right?
Yeah, right. Yeah.
You take, like, there's only so many different OSPF area types. If I'm going to set up a BGP peer, I know what best practice is, right? And one of the things that's continually changing is the technology and, the latest and greatest from our suppliers. What's the latest implementation that Arista's got, or Cisco or Juniper. And so you're kind of pattern matching, right? What are my best practices? What are my design principles? What's the latest technology? What are the bells and whistles that I can use? And then I'm bringing my constraints. I'm going to have constraints around budget. I'm going to have constraints around reliability metrics, about capacity, forecast, demand. And guess what? That forecast just got a lot easier, because out of the day 2 and the day 1 AI system, we've now got data that we can actually use those time series foundation models to give us forecasts on that are way more granular than anything we've been able to do in the past. Right?
Yeah.
Now we've got really nice forecast data coming from our AI system, not from a spreadsheet that someone updates once a quarter, right?
Yeah.
So all of that's feeding in. One of the things that's kind of key, that actually, I think is the limiting factor is, as a network engineers, we're risk adverse, So we need to cater for these unforeseen circumstances. And so we need to be thinking about those best practices and hedging, right? One of the things that will help us be more, and to be honest, from my time at Cisco and Juniper, most often you develop these fancy new features. Like I still remember Juniper having LSP, auto bandwidth and auto scaling. And like next to nobody used it. No one used those really advanced features, because as soon as it got like even more complicated for engineers to anticipate how it might behave in certain scenarios, we were like, actually, you know what, just keep it simple. Because then I know in all these different scenarios, these failure scenarios, these peak load scenarios, maybe I've got a better understanding how it's going to operate. Well, the solution to that is back at the design stage. Why don't we simulate it? Why don't we simulate not just one layer of failure, 2 layers of failure? Why don't we simulate 3 failures across all the layers in the stack, across the domains, right?
Yeah.
So as we start to get to that, we can simulate things that gives us a lot more confidence to actually how we design it. We could get to running the networks hotter, as you said. We could get to networks that, one of our cardinal sins in network is that we've often gold-plated best effort. No.
So true.
Right? So it's like all of a sudden, best effort's been good enough in a lot of cases. So, if we could run our networks and give truly differentiated services, because we've now scenario modeled it out, we can see what happens across traffic classes in different failure scenarios. That's going to give us that confidence, right? That gets us over that cognitive bias of wanting to err on the familiarity bias, right?
Yeah.
Confirmation bias. So I think that's really the big unlock we get here. That's going to require us to turn our head upside down. Do you know what I mean? Like, there's going to be fundamentals that we've just lived with for decades that we're going to need to rethink. But that's kind of the opportunity we see where we're going.
Yeah. Yeah. I think you're kind of like right on. This is like clearly the direction, that we have to get into the industry. And frankly, I think it's sooner than a lot later, that we have to be there. Like the velocity and the scale and the size that AI is coming on to us, and also within the enterprise, as well. These AI workloads are also creating very different kinds of traffic patterns, really almost like Brownian motion, some things that we didn't even envision, before. Almost like Pablo Espinosa within your group. I'm sure you probably know Pablo. Ben. Pablo likes to talk about like it inverts, our expectations of what networking really is. And so, these kinds of tools where you can really model and understand the dynamics that are happening within the infrastructure, and that assist you both in terms of the operations of it, and then also, I think important, especially for this new phase that we're entering into around design, is extremely, extremely important. So I want to shift our attention a little bit. We have, we do have a few more minutes, but I would like to get to like two other topics. One is that, IBM is really in a great position because it's always straddled both the service provider space, in essence, the telco space, and the large enterprise. And the telco space, I think, has been a little bit more advanced in their AI ops kind of deployments than the large enterprise. And I think that gap is going to narrow pretty quickly. So is there anything that you can think of from that you might have learned in kind of the telco space that could be applied towards the enterprise marketplace? Like maybe either a best practice or maybe the area in which to focus on first, and to get that underneath your belt so you can build upon.
Yeah. Look, I think one clear thing, is that the telcos have really pushed the boundary on scale, right? When it comes to networks. So obviously, you've got the hyperscalers out there, competing with them on network scale. But the telcos have really pushed the boundary of those systems, but as you mentioned, across the entire observability kind of category. So I think that's useful. Fundamentally, they do run into these same issues that enterprises run into as well, and so they feel the impact more so. So, the problems they run into, come from the same issues we've had, using machine learning algorithms for the last 15 plus years, right? It's it really draws back to the fact that our systems, our observability systems, and this is what I'd argue is, this is not a problem of observability anymore. This is a problem of AI, because the machine learning algorithms, they were very task specific, and you needed a whole bunch of algorithms to try and find that signal from the noise. And in reality, the only thing we were able to identify in anomaly detection was statistical relevance. We might say these two things happen at the same time multiple times. We've got no idea why, but we'll throw that up to you, the user. You go find out why, but we tell you they're related. We know that much, right? Sure. AI is going to solve that. That's going to actually bring that knowledge, to bring the network knowledge in. So that kind of helps us there. So I think that's going to be relevant. To give you an example that we see in telcos that run large IP-based packet networks, that is very relevant. The work we're doing in the banking sector have seen this to be true as well. There's a common issue people refer to as silent packet drops. So I talked before about trying to get, beyond the kind of the threshold problem, or trying to have the AI system be thresholdless. Well, how do we get beyond the alerts? The alertless problem, like silent packet drops, is going up. There is no alert for silent packet drops. That's why they're silent. And they can happen due to a whole bunch of reasons. One common one we hear, just a simple example, is MTU mismatch. But these IP networks typically all multi-vendor, right? Yeah. And so systems that are siloed, will often miss that. And you can have one end of the link thinking it's fine and the other end of the link silently dropping. So what you can see, though, that there's a pattern, there's a signature here. If you're looking at the right metrics, or the right SNMP, or the right streaming telemetry data, and we're looking at that in unison, we can actually see the pattern emerge across either ends of that link for the input-output counters as well as the jumbo frames counters, and we can catch that. So that's what the AI, we can train it on these patterns to catch these alertless issues. Now, what we find there in the telco domain that has a lot of that is relevant in the enterprise domains, and banking and finance that continue to want to run infrastructure so they can have reliable systems for their clients. See huge value there too, right? Data center, great example, and especially all the innovations happening around data center and fabrics right now, and just how critical those fabrics are for AI data centers, but across both training and inference, right? So I think that's where I'd point to. We learn some of these things in terms of impact and scale in telco, but they cross-pollinate back into enterprise, absolutely.
Yeah, that's a great example, and also great learnings, from the telco industry and how that can relate to it. I love it, like, silent, packet loss or silent droppings. Actually, haven't heard of that before. I'm so surprised I haven't heard of that. But that's a great example, of those kinds of signatures and scenarios. So I want to go to like one last question, and it's interesting because like now in most in large enterprise, either you're getting, and this is I think the dominant, is that most boards are pressuring CEOs to get on board with AI really quick. And so it's coming top down, and it's coming bottom up because like everyone's just kind of using these AI tools. So in this scenario though, is that I'm not sure how much is going up. Meaning that a CIO goes to their CEO and says, "Hey, I want to do this AI project," and so they get resistance. I don't think that's happening very often, but I think maybe it's like from the point of view that what we are seeing is that like 96% of Gen AI projects within the large enterprise are failing. So, and a lot of that is because they haven't invested in the infrastructure to get the infrastructure ready. So I think, maybe, so this is the question, Ben, is that, if you have a CIO that goes to their CEO and their board and they're saying, listen, we want to be prepared, for AI. And so what might be like the minimum kind of project that they can do like within a 3-month time frame that kind of shows, readiness and shows that there's a good return on this investment. So when do we take it from that point of view is that, and this is going to be a major theme within the summit, is that you've got to get the infrastructure ready. So what can they, what can you be doing like in a, let's say 90-day, 3-month time frame, that will kind of prove the point and make everybody feel comfortable?
Yeah, I'll tie this back into something we were talking about before, but just before that, I think with this question, it's really important. We need to think about a couple of time frames. And so you're absolutely right. People aren't having too much problem to say, right, hey, trusted engineers, trusted managers, trusted CIOs aren't having a problem saying, hey, I found a really great AI project that we want to run. People are saying run it. So we're kind of in that like expansionary, let's try lots of things and see what works kind of phase. That's the current time. But guess what? The time is going to come, just like you see in SaaS today, where it's probably not the CEO, to be honest, it's probably going to be the CFO who's going to come and say, hey, you know what? You hear it with tool proliferation, right? You've got 20 of those projects, you got 20 of those SaaS products, you got 20 of those automation tools right now. You're allowed 5. Pick your 5 for next year. The consolidation is going to come, right? So we have to anticipate that. So it is important to think about, as you say, the building blocks, the infrastructure, and showing success along the way. Now, one thing I want to take back to what we talked about before, right? The agentic space, it is moving so quickly. I mean, what we've seen with the improvements in reasoning, right, has been, huge. We also know there's lots of things that haven't been solved yet. Like we just talked about multi-agent collaboration, like MCP, the goal alignment problem, and handling things like AAA for agents, So until that kind of gets solved, you've got to acknowledge that's probably not a production system, right?
Yep.
I think we've got some big footsteps to follow in here. If we go back to how cloud got adopted, there's dev test, right? You can show success in low consequence environments, and dev test good example. I think there's another way, because we're focusing initially, again, another subliminal message on day 2. If we focus on systems around observability, there's an opportunity, just like you would go in a medical context. If you want to get a second opinion, no one really questions you going to another doctor, getting a second opinion. Doctors vary, right? They have different expertise. They'll have different preferences. They'll be up to date on different sets of research. To be honest, it always scares the heck out of me when I hear that research about the judges and from a legal context, when you see what their sentencing patterns are based on the time of day relative to how hungry they are, you know, and you get pretty lenient sentencing at the start of the day, and it is pretty bad idea to be on just before lunch, right?
Oh my God. Very important note. I take note. All right.
Justify going down the dev test path with a second opinion system. So a system we could put in a dev test environment that runs alongside some of our existing observability systems. And the metrics you want to focus on, and coming back to the fact that we know agents are important, they're going to be very important, and we don't have everything we need to put them in production right now. So we need to complement them with analytics, right? So first, analytics, let's say in that second opinion, can you give me a system that analytical and agentic can show me things that my current systems show me for observability? Let me just get some confidence that you're not missing things that I'm already getting. But that's not it. Show me you can do that with more accuracy. I want less false positives. Okay, great. What else? Show me the things that you can find my current systems can't find. That's the alertness. Show me the silent packet drops. Show me where they've got issues in the network before my users complain, and it's an intermittent issue and a nightmare to troubleshoot that can span weeks, right? Show me those, all right? And then next, show me the thresholdless issues. Show me the things that are degrading before they hit the threshold, right? Now, we can show output on that out of the gate, right? And that's building trust. And then you can show the agentic piece, which doesn't have to be, let loose on automation that could, bring the network down. It can be automation that the agents are showing how do we identify what the root cause to these issues are and what should we do about it? What's the remediation plan? There could be a fully formed automation. It could be an Ansible playbook. It could be an API call. It could be a low-code, no-code workflow, right? So that are the things that can be done in short time frames with real data in your environment without threatening front page kind of news headlines, right? So I think those are the things, but we've got to bring the analytics piece, and we've got to kind of acknowledge where the agents are today relative to what we need them to be for production.
Yeah, awesome. Yeah, that actually really, really great, advice there. It's like, make sure you're not doing something on critical infrastructure, during this kind of like, initial process. I think, Ben, this was like really just great. I think I learned so much, from, just like talking with you during the hour and also getting a really good sense of really where IBM is in kind of its, autonomy around networking and how automation is now coming into the infrastructure and where you guys are leading in that space. And as the more that you were kind of talking, the more that I also realized too, is that what's really unique about IBM is that, you're not selling, the hardware, you're really, and I think you need that in this industry. You need that kind of separation, because if you look at all of the vendors that you mentioned, whether it's a Arista or a Juniper or a Cisco, they're really not interested in a kind of a multi-vendor, solution set. So you need an independent entity, and that's really where IBM is stepping in, is to really provide that independent, cross-domain, cross-vendor, lifecycle management service. So that's really powerful. And then I didn't really connect the dots around what's happening in the agentic world with, I think, the expertise that we have in the networking space and how much we really have to offer. And tying those communications in and tying it into policy, the access to data that we've always been so strong in, whether it's roles-based, identity-based, and so forth, policy, governance. So there's a lot that I think in the agentic space that, our industry is really going to control, or, has a really great opportunity to control.
Yeah.
So I thought this was like really great, Ben. And any final words before we end?
No, that's great. I think good summary there, and I'm I didn't want to say it, so I thank you for calling out. I mean, it is an advantage from IBM that and we'll work with all of the players in the network ecosystem. That's something that we can really do. We can really bring to bear here for networking, right? But no, I'm looking forward to the event next week and continuing the conversation and what this might spark in terms of people we get to chat about on the floor. So yeah, look forward to seeing you next week.
Awesome. Great. Ben, thanks so much. And thank you everyone for plugging in.